Here in this video, we would like to talk about a law called Boyle's law, and then we'll also talk about another law called Charles' law. So first, let's start with the Boyle's law of gases. So first thing is, this law is, so the law says for a given mass of the gas, volume of the gas is inversely proportional to pressure, or vice versa. Pressure of the gas is inversely proportional to volume, or pressure into volume equal to constant. This is called a gas law, called Boyle's law. So what is this law? If you draw a graph taking the pressure on x-axis and volume on y-axis, the graph shape will be something like this. Be careful, this is valid at constant temperature. Boyle's law is valid only when the temperature is kept constant. So we can say for given mass of a gas at constant temperature, pressure of a gas is inversely proportional to volume. If you keep the temperature constant, actually that process is called as a isothermal process. So in isothermal process, pressure of a gas is inversely proportional to volume is the Boyle's law. Now say for example, when you are trying to verify that Boyle's law, you take gas in a, say, test tube. Imagine there is a seal on the top, so you have a gas here. So for this gas, volume means volume of all closed space. But if you take this kind of a tube whose area of cross section is constant, then I can write pressure into volume constant as pressure into volume of the gas can be written like area into length of the gas, where this is the length and this is the area of the cross section. As anyway area is constant, we can further prove pressure into length is constant by area, that is equal to another constant. So here in this case, rather proving pressure is inversely proportional to volume, when you come to an experimental level, we can prove pressure is inversely proportional to length. You probably remember that you do an experiment in the laboratory called something like Quill's tube. In that Quill's tube, instead of finding out pressure into volume constant instead of showing, you show that pressure into length is constant because of this reason, because its area is anyway constant. That's what the basic thing of Boyle's law. Now we'll talk about another law called something like Charles law. So the Charles law tells you that at constant pressure of the gas, volume of the gas is directly proportional to absolute temperature. Be careful, this temperature that you are measuring is absolute temperature or Kelvin temperature measured in Kelvin temperature. To convert any value of the temperature in degree centigrade into Kelvin into absolute temperature, you have to add 273. Then it becomes a Kelvin temperature. So Charles' law tells you that at constant pressure, volume of a gas is directly proportional to absolute temperature. So you have different volumes at different temperatures, and you can say T1 by T2. Proportionality can be eliminated and the proportionality can be eliminated with a constant. This kind of a law is called something like a Boyle's and Charles law. Now, it's very clear that being that is directly proportional to temperature, if you take the say temperature and volume on x-axis and y-axis, say volume here and temperature here, the graph is going to be, as they are directly proportional, a straight line passing to the top of the origin. And you can say in another way also, there is another way, right? What we can say is, at constant volume, pressure of a gas is directly proportional to absolute temperature. I can say in that case, P1 by P2 is directly proportional to T1 by T2, or can also be written P1 by P2 as T1 by T2. But be careful while we are solving this, while applying these laws, that this temperature shall be always taken in Kelvin, absolute temperature, never in centigrade. That's a basic rule to solve these problems based on gas laws. In fact, if a gas, if it obeys all gas laws, so we can say, if a gas obeys all gas laws, like Boyle's law, Charles' law, Avogadro law, all gas laws, at all temperatures and pressures, at all temperatures and pressures, that kind of a gas is called ideal gas. That kind of a gas is called ideal gas. But practically no gas is ideal because they can't obey all gas laws at all temperatures and pressures. The gas, these gases that what we see in our daily life, gases, our regular gases obeys these laws at only high temperature, so that it behaves like more gas, and low pressure. At high temperature and low pressure, all these gases actually behaves like ideal gases, and that kind of a gases are called real gases. So what we see in our daily life are real gases, but if there is a gas that is having properties close to ideal gas, that's not ideal but close to ideal gas, is something like hydrogen. All other gases could be called like more like a real gases which obeys gas laws only at high temperatures and low pressures. This is what the basic aspects of Boyle's law and Charles' law. In further videos, we will try solving some problems of Boyle's law and Charles' law. That's it. Thank you for watching.